This is a review of esterification reactions for Alberta Chemistry 30 organic curriculum. In this example, I have ethanol as an alcohol reacting with methanoic acid. For esterification reactions in Chem 30, it's the only time you're going to see two organic reactants. So that should jump out to students as something is different, and this particular classification of reaction. Okay. Now, students don't need to know how they occur, but it's very useful to have some idea to help you predict the products properly. And it's the O on the alcohol that ends up connecting to the C that's surrounded by the double bonded O and the OH, the carbonyl and the hydroxyl group. Okay. So I'm going to draw what happens when these two molecules come together, and I'll leave the color coding of the blue and the black piece. So the blue is coming from the alcohol. It's a 2-carbon long alcohol, and that blue O is what makes the connection. All of the blue carbon to hydrogen bonds do not change. Okay. The blue O to H bond will be broken. Okay. And that's what allows the blue O to connect to the black C. And there will still be a double bonded O and an H. Okay. 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 Now you will see the hydroxyl group come off, and when you combine that with the blue H from our alcohol, you get a water. Whenever you do an esterification reaction with an alcohol and a carboxylic acid, you always get an ester and water. This is our ester, and they're used a lot in the food industry because they tend to have nice smells, and this is how you can synthetically produce a smell in something like gum or a food product. Now, in order to run this reaction, you do need a catalyst. You need an acid catalyst. Okay? One of the most common ones used is sulfuric acid, and that's the one we use for our ester labs. Okay? Last is naming esters. I'll include as part of this review. You always name the piece that comes from the alcohol first. And in this case, that's the blue color-coded piece, and that's 2 carbons long. So we're going to use the F for the fact that it's 2 carbons in the alcohol piece, and add YL to denote the first piece of our ester. Okay. Often I'll put a dotted line through the O just to cue my brain of the 2 sides of our ester. Okay. We name the piece from the acid second, and that becomes our parent or our stem. That's 1 carbon. So that's meth, so we're going to use the methane part, drop the E, and we add O8 for an ester. Okay. So that's a common thing done in organic chemistry. Use the stem name, A and E, drop the E, and add the ending. Okay. So ethyl methanoate is our ester. That concludes this review of esterification reactions as well as naming esters.